And we are starting the third panel of this morning. Its title is Preparing Our Workforce for the Digital Age. And we have here with us Mr. Sebastian Bardy, Mr. Paolo Neirotti, and Mr. Pedro Arrazola. Welcome everyone. Mr. Bardy is from Technical University of Darmstadt, Germany. Mr. Neirotti from Politecnico di Torino, benvenuto, and Mr. Arrazola from Mondragon. We are starting with Mr. Sebastian Bardy from Technical University of Darmstadt. Mr. Bardy.
Hello. Now I had a connection problem. Okay, now. Welcome to my small presentation about Human in the AI Loop, our project at the EIT Manufacturing. I wanted to start today with a German newspaper article I just read today, this morning, about a representative study conducted by the German company Bosch with a German market research institute. The idea of the research study was to identify artificial intelligence in and the connection to society, as well as the problems that arise with it. The interesting stuff about the study was more than 1/3 of the participants are actually scared of AI at the moment. The interesting part about this is Bosch says in the study they want to enhance all their production lines until 2025 with artificial intelligence. So this is just an example how relevant and up-to-date artificial intelligence is at the moment. And please go to the next slide. In our research project, we actually try to identify what are the challenges of artificial intelligence in production concerning blue-collar workers. So at the moment, I think all companies are very focused on data scientists, engineers, all the specialists that actually implement artificial intelligence in production and try to get those products to the production line. But what we are focusing on are the blue-collar workers, those that are actually using artificial intelligence, are not prepared yet for the new technology. So the question is, those blue-collar workers, what do they actually need to know about artificial intelligence? So from a maybe technical point, what is the technical knowledge they need to acquire to use artificial intelligence? And what is also the areas for the blue-collar workers that they are going to work with AI in? So for example, are the blue-collar workers the ones that train the AI? Or are those maybe not the perfect people to actually have knowledge about problems that could be solved by AI? So on the other hand, we have those prejudices or the fears of the blue-collar workers that are going to work with AI. And as the study just said, what I said in the beginning is there are actually 1/3 of the people still scared of it. So how do you get this challenge done, or how do you train your blue-collar workers to not be feared of artificial intelligence and actually help in the process to enhance your production? So this is the challenge we try to solve in our research project. Please, the next slide. So what we are doing, or what we did already, was we try to focus on use cases in production, try to find where is artificial intelligence used in production already, and how can we actually teach blue-collar workers to use this artificial intelligence without mathematical equations, without all the focus on actually implementing and more on using. What we did is we have the guided learning platform of the EIT Manufacturing, where we have lots of learning nuggets that try to explain artificial intelligence to blue-collar workers on a simple level, and also focusing on fears and prejudices that actually arise with artificial intelligence on a production floor. That's actually the presentation, and thank you for listening.
Thank you very much to Sebastian Bardy. Now we have from Torino Politecnico University, Mr. Paolo Neirotti. Dottor Neirotti, a lei.
Grazie. Thank you very much, and good morning, everybody. So I'd like to talk a bit about the way we think blue-collar workers or even supervisors, team leaders, low-level specialists in factories should change the way to work because of more technologies. In this perspective, we have built a short course for EIT Manufacturing that exactly talks to HR specialists, production directors, process engineers in the manufacturing realm to understand how to work on that. Next slide, please. Okay, so this course really provides a bird's-eye view on the digital transformation of work. So next slide. So I think these slides can be skipped. Probably will use the slides at a very general level. Anyway, in this course, we try to condense the best of our research that we have conducted at Politecnico di Torino on different industries, both manufacturing and maybe network sectors. For example, our experience for the energy distribution sector is we have introduced IoT in the electrical grid. We are monitoring real-time the electrical grid. We are using data scientists. We have developed and deployed machine learning algorithms for predictive maintenance, but in the end, the only guys that are able to detect false positives signaled by the algorithm are line employees, because they have in their gut, in their bell, a type of tacit knowledge that can be hardly codified and then serves to contextualize what data and algorithm are saying. So this is a game changer, I would say. This is a game changer for human resource management systems in many factories. The way human resource line employees, and especially blue collars, are managed are still in with the lenses of Fordism. So no involvement, no variable remuneration for suggestions and improvement and suggestion for improvement. And so in this course, we try to condense the very best of our research that we did in the last few years. Not just at Politecnico, there is a stream of studies on this. By the way, our perspective, I'm not an industrial engineer, I'm a management engineer. So my disciplinary background is more really on the interdependencies between the technical system and the social systems that you have in factories. And I think this could be the socio-technical approach, the right way to look at the digital transformation of work in factories. Under this point of view, I think so there is. It's not just a matter of skills. Of course, blue-collar workers need to have, for example, more learning orientation, more orientation to try to understand and interpret what data are saying, trying to balance, they have to try to balance what the algorithm are saying with what theory are saying. So, for example, today in factories, also as a line operator, you enter with a diploma, you enter with a degree. And so under this point of view, also all the vocations. So there are enormous enormous implication for education in the vocational and education training systems for technical schools, for universities, and stuff like that. So there is an issue about skills. You have to teach, you have to transfer line operators and blue collars, soft skills, learning orientation, problem solving, attitude, and blah, blah, blah. Under this point of view, lean production systems have made a lot of effort. And so in this course, for example, we underline how lean companies, so companies that have implemented a lean production culture extensively, are more ready to embrace digital transformation and AI. There is an issue to teach statistics to line employees also. What is a variance? What is a standard deviation? What is a moving average? So very simple statistics that should enter into the technical vocabulary of line employees. But then there is also an issue related to how to reconfigure the human resource management system of factories. So factories today are no hierarchical. So because team leaders can easily talk with the production director in order to discuss about how to approach a particular technical problem. This already occurred within production, but this trend is reinforced with AI. So you have more vertical and also horizontal communication flows inside factories. But of course, to build this configuration, you need to re-engineer completely or extensively the human resource management system. So in this course, just to conclude, we try to illustrate all the building blocks of this transformation, in this way, and this type of illustration is intended for human resource specialists, for production planners, for process engineers. So to everybody that in the end is involved in the way work must be designed and must be implemented into a factory. I'm done. Thank you very much for your attention.
Thank you, Mr. Neirotti from Politecnico di Torino. Now we have from Mondragon, Mr. Pedro Arrazola. Good morning again, Mr. Arrazola. We cannot hear you. We cannot hear you. Still we cannot hear you. Maybe your microphone is off. Mr. Arrazola from Mondragon is trying to put the microphone on. Still we cannot hear you. No. Mr. Arrazola? So I go for the questions that I have from our public, and then we are waiting for Mr. Arrazola from Mondragon to put his microphone on. And I have a question here for Mr. Neirotti, for you. You have mentioned about the issue of skills.
Can you hear me now?
Yes, yes, I can hear you.
Okay, sorry.
Yeah, so we skipped the question later for Mr. Neirotti, and we are listening now Pedro Arrazola from Mondragon. Welcome again.
Okay, sorry for that. Okay, good morning to everybody. So today I introduce to you MAC 4.0, a training and learning activity created in the guided learning platform of EIT Manufacturing, which demonstrates the practical and application of Industry 4.0 and more specifically artificial intelligence to machining processes. The project is led by 4 university partners, all experts in machining: Mondragon University, Politecnico di Milano, University of Prague, and Technical University of Darmstadt. Next slide, please. So, can you imagine a world of zero defects in manufacturing or machining? Manufactured components with the right dimensional and geometrical tolerances, better surface finish and surface integrity. no scraps at all, less material waste, less pollution, and lower energy consumption, what we call the circular economy. Well, it seems impossible, doesn't it? But what if we could? Next slide, please. Yeah. The way we produce products is undergoing a significant transformation driven by technological innovation, what we call Industry 4.0. And one of the key aspects for this transformation is artificial intelligence. When analyzing machining process data in a conventional way, it means that expert knowledge is necessary to develop programs and rules. In-depth understanding of the process is required, and development requires a great effort and takes a lot of time. Okay. So we want to use artificial intelligence in machining processes to match machining data with quality component data, okay? And we want to train algorithms. We are going to use much more data sources, okay? And we want to develop models that are we want to develop models in a faster way. Basically, artificial intelligence learns from experience, from past experience, what we do every day, okay? Adjust to the new inputs and performs human-like tasks. Next slide, please. Next slide. Can you hear me? Okay, well, I'm looking for the next slide. Okay, yeah, well. So, there are 6 steps to develop machine learning models based on production data. Well, the first one is to frame the problem, and the second one is to obtain the data. We want as well in the third one to explore the data. We want to prepare the data, then we select and train the models, okay? We need to select what are the best models that are suitable for our case study. And finally, in the sixth step, we fine-tune the best performing models. Basically, what we do in artificial intelligence, apply it to machining, we gather data from signals such as cutting forces, power, vibrations, temperatures, some of them from external sensors that we put in the machine, other ones coming from the machine tool, okay, what we call internal sensors. And these signals are combined with product quality data, okay, such as dimensional and geometrical tolerances, surface finish, surface integrity, and so on, okay? And the idea is to develop trained models that put in correlation the signals, the internal signals, with the quality product, okay? The final goal is to monitor the machining process based on the signals that are coming from the machine tool and to ensure the quality component. We clearly believe that artificial intelligence can bring us one step closer to the zero defects goal. Next slide, please. So, the artificial intelligence created in MAC 4.0 can help current and future workers solve some of the common problems in machining processes. This program employs a mix of practical and theoretical lessons delivered in both face-to-face and remote formats. And in this innovative practical program, we look as well to concepts such as modeling and digital twins, process simulations, zero defects, process monitoring, data analytics, big data, selection of working conditions, machinability, surface integrity, and so on. And of course, we look as well to the real impact in manufacturing. Something that is important is that the access to the guide and learn platform of EIT Manufacturing will be free in the future. And for the conclusions, the benefits of applying artificial intelligence in machining is clear. Smarter manufacturing means increasing your competitive advantage. It means increased efficiency, better quality products, and reduced waste. Of course, better for you, better for the customer, and better for a more sustainable and competitive Europe. And that was what I wanted to share with you. Okay, thank you very much for listening to me.
Thank you very much, Mr. Pedro Arrazola from Mondragon. Now I go back to the question for Mr. Neirotti. You were mentioning before about the skills, issue of skills. And the question is about these skills for you. Is there any awareness about this? So people and the factories, they really understand that there is a lack of skills for this kind of job.
Thank you for the great question. I try to go more in depth on what I have said. I think that also Sebastian Bardy with his presentation has to say something of important on this, because I liked his presentation very much. Well, for example, soft skills. The debate on soft skills is a little bit all-defined. So why soft skills and which soft skills? So for example, in the moment you need more involvement in the decision-making process or in the analysis process enabled by artificial intelligence, it's clear that you need to have self-efficacy. So people, like blue collars, need to think, okay, I have something to say and to add to the continuous improvement and to the innovation process of the factory. Second is leadership. We have seen in many factories that if line operators have a good team leader, have a good leader, the leader is a very important role in persuading his or her subordinates to bring out ideas. So, and leadership is something that, for example, is not taught in universities or in engineering, in the engineering curricula, for example, but also in technical schools. Okay, and then of course statistics. So statistics is not taught, at least in Italy, in technical schools. So we could go ahead with these more at the micro level, but I think that in general this is the point. By the way, the evidence from labor studies say that when you provide more of these skills to line operators, the dividing wage between professionals, specialists, managers, and line operators is shrinking, which means that this is a tremendous opportunity to train people also to in order to reduce the divide ignited by such a technological change. So there is a lot of attention on the fact that data scientists are sexy jobs, are very well paid and very well remunerated. But in the end, if you are trying people on the line with such skills to be involved in the loop of artificial intelligence, of course you have better products. Better products means more economic value added. More economic value added means higher wage. Higher wage means higher living condition for everybody. And this is the way, the high road to face the controversial issues of such a digital transformation.
Thank you very much, Mr. Neirotti. Mr. Bardy, as Mr. Neirotti mentioned here about this issue, would you like to add something?
I totally agree with him. It's really the task for the next decade to decide what are we going to do with blue-collar workers in a more digitalized and automated world. And I think that's exactly what he said. And I have nothing to add there.
Then I have a question for you. When you were talking about the challenges, you said that they are prejudiced about artificial intelligence. So can you be more explicit about this kind of prejudice? Who and which kind of prejudice, please?
I think the biggest prejudice is always, is AI actually going to replace me in my job? Can I be the one that when I train the AI, am I going to be replaced by the artificial intelligence after I'm finished training this artificial intelligence? And if you're not really in depth into artificial intelligence, you might actually think of it as a perfect machine that can replace you. And I think that's one of the biggest fears or prejudices blue-collar workers have when they hear about artificial intelligence at their machines.
Very clear. Thank you very much. The last question for Mr. Pedro Arrazola from Mondragon. Mr. Arrazola, you were talking about the benefits in last part of your speech. And you said that it reduces vast pollution, and of course there is also the possibility of lower energy consumption. It could be applied, this what you said, for all sectors, or there are specific sectors that they can have benefit of this process?
Well, what I meant by that was that we will be able probably to do the first part right with more easily, okay? So we will not have scraps, so we will have less scraps, so we'll reduce the material waste, the consumption of energy, and so on, if we analyze in a better way the process. And this, well, the methodology can be applied no matter to machining, but it can be applied the next day, well, of course, adapting a little bit, but it can be applied to foundry or other processes like sheet material forming and so on. Okay, I don't think that is only. I was talking about the machining, but it can be applied to any kind of processes, manufacturing processes. Yeah.
Thank you very much for your contribution to World Manufacturing Forum. We are concluding here the third panel, and we are going to last panel, and its title is EIT Regional Innovation Scheme as an accelerator for the digital age. And we have two speakers for this panel. We are welcoming Mr. Gonçalo Figueira from INESCTEC and Mr. Kosmas Alexopoulos, LMS. Good morning.
Good morning.
We are starting with Mr. Figueira.
Thank you very much. So in my presentation, I will try to give an overview of the projects that we have been developing in the area of artificial intelligence for manufacturing, and also try to give some perspective of how we see this area evolving in the future into more explainable and more collaborative AI methods. So in the next slide, I give some examples of the projects that we are approaching right now. So they cover a variety of different problems that go from failure detection to process control to defect detection, quality control, computer vision, robotics. So a lot of different disciplines that we are including in these projects. But just to give you some examples, for instance, this Zero Defects 4.0 is a project that we have been developing in the context of EIT Manufacturing with Sonai Arauco, which is a company that produces wood panels. And the challenge there is to identify the key parameters that really impact quality and defects at the shop floor, so that we then understand how we can improve manufacturing decisions and improve product quality at the end. So the idea is that we go towards these zero defects targets, right? So for that, we use different methods, machine learning methods and optimization methods. Then this second project of process control is actually a little bit similar, but in this case with a glass manufacturer. So the challenge there is to really learn this process control policy that will in real time adjust the control parameters like temperature and pressure, so that we take into account and we adjust to the changes that will occur in the process. So considering external variables like temperature, considering that the manufacturing molds also deteriorate over time. So we need to learn this real-time policy with machine learning methods, and in particular with reinforcement learning. And the final example, this predictive maintenance project, where we start by detecting failures and then understand what caused those failures, so doing root cause analysis. And based on all that information, then we try to predict when we will have those failures and what type of failures we will have. So we use here a variety of different methods, different machine learning methods, and the main challenge that we see with all those methods, I try to illustrate it in the next slide. So is that these models are black box models in most of the cases. So in the next slide, please, we can see, for instance, a neural network or a tree ensemble would be not be able to be explainable, not just to blue-collar workers, but to managers and even to researchers. So no human being could really explain what goes underneath these models. So it's really hard sometimes for managers to trust these models. And what a lot of people are doing in this area of explainable AI is really to create, on top of these black box models, try to create explanators that would somehow mimic the behavior of the black box model, and they would be more simple models, some models that we can look at them and understand them. The approach that we see that could be more appropriate in many cases is not to do this in a two-step process, but really directly learning an explainable by design model using symbolic learning methods. So that's the purpose of this European project, Trust AI, that we are coordinating alongside other partners. And the purpose there is to build this framework where we create these explainable models and we present them to human beings that can be managers or researchers, so human experts that can look at those models, interpret those models, modify those models, and really contribute and guide the machine learning process. And at the same time, they can also ask questions to those models, like why was solution A chosen rather than solution B, or more generally, why solution A was chosen at all. Okay, so we can apply this Trust AI framework to a variety of different problems, and I try to illustrate that in the next slide. So that includes, next slide please, that includes predictive problems like forecasting demand, predictive maintenance, as I shown before, also interesting problems like predicting human activity, which is quite an interesting challenge and an important challenge when in the context of human-robot collaboration, which seems like a hot topic right now and was presented before by some of the speakers. So we can approach these predictive problems, but we can also approach prescriptive problems. So real-time decision-making problems like production scheduling, process control, inventory management, and vehicle routing. So with Trust AI, we are approaching all these four prescriptive problems and also some predictive problems. So that's all from my side. Thank you very much.
Thank you very much, Mr. Figueira. Now we are listening to Mr. Kosmas Alexopoulos. Welcome again, Mr. Alexopoulos. We have a problem with the microphone, Mr. Alexopoulos. Microphone, your microphone.
Now?
Yes, we can hear you now.
Okay, so again, hello. I would like to thank the organizers for the invitation to this panel that discusses manufacturing in the digital age, in the so-called digital age, or if I may say, to the artificial intelligence age. So the manufacturing sector is one of the leaders in application of AI technology, as there is a lot of promise and expectations behind artificial intelligence to contribute to significantly cuts in unplanned downtimes, for example, or to improve the design of the products. And for these reasons, manufacturers are applying AI-powered analytics upon data in order to improve efficiency, product quality, and safety of employees, among other issues. So AI is relevant for different areas, different application area in manufacturing, and in manufacturing research, we are quite used to model this setting using a hierarchical approach that we are presenting in this slide. So at the low level, we are focusing on the field devices and the tools that are there to process the products and the parts. And so we have the process level, and in this level, AI is relevant for optimization, quality assessment, adaptive control, and so forth. Then if we go to a higher level, then there we see more complex mechatronical assets, such as, of course, robots, industrial robots, that need intelligence in order to be able to handle the production of complex products. In this layer, Issues like autonomous control of robots, motion control, human-robot interaction are relevant applications for AI. As with this technology, this process can become more flexible and can adapt to product variations, they can adapt to downtimes, they can adapt to unexpected events, or contribute to other phases of the manufacturing life cycle, such as programming and reprogramming, configuring and reconfiguring mechatronic device. So AI really can contribute and can be a winning element in this area. Then going even a step higher level, we have the so-called systems of systems, or systems and network. So when we're in for example, factory level, or when we see the supply chain level, when we have this horizontal integration in manufacturing, AI is again very much layered. Also in this, as the layers increasing, then we also have more data available, so we can do more stuff, let's say, with AI, by utilizing also the data coming from all the layers below. So there are functions such as production planning, of how to optimize the production, how to optimize scheduling, how to support operators in such more complex settings. In such settings, AI, of course, is still relevant, very relevant. And then as background framework, in order to support these functionalities, we need software and platforms in order to help the setting and help the development and deployment of intelligence in the manufacturing environment. If we can go on to the next slide, please. Thank you. So here in this slide, we will see some examples of AI that we have are been working in the past years in our lab, and now within also the context of EIT Manufacturing Regional Innovation Scheme Hub in Greece. So one application is the fusion of physics. So there are models that capture how a system behaves, how a system works. This is also in many cases referred to as the digital twin. So we are developing methods by applying the digital twin concept that basically relies on the fact that we need to combine simulation results together with real-time data in order to predict the system behavior, such as potential failures, or so we can apply proactive strategies such as predictive maintenance. And this scheme is based by combining real-time data with simulation data, and have predictions, for example, on the operation of a robot. Another area that we are working is focuses on robotics, practical and mainly, and there the key objective is how to control the robot, how to generate the motion of the robot, how to make the robot adapt to new products, or adapt to changes in the production, or interrupts in the production, or, for example, when we're talking about mobile robots, how to generate motion of robots. In there, we have developed AI methods based on heuristics that can be configured in order to optimize motions, taking into account constraints such as, for example, objects, so we can have collision avoidance. And in that matter, robots can act more autonomously in a manufacturing environment, or with the same principle through heuristics, that they can search in a large solution space in a very in a quick manner, in a quick way, a robot could adapt also the task that it should perform and how to perform with which tool, and also in collaboration with some human. So same principle can be applied in different cases. Going even let's say upper in this layer that I explained before, we have an example of adaptive scheduling. There is to use AI based on heuristics, but also other principles, also with the data-driven approaches such as the neural networks. You can help the production planner to adapt the production in a factory level, in a plant level. For example, when there is a material shortage, so some unexpected event or some machine may break down, AI could help and provide suggestions to the planner in order to address and compensate for such shortcomings. And this is also an area that we are working heavily in the lab, and we have applied to several cases in manufacturing. And as I mentioned before, we have in the fourth area, it's the services. It's actually the system. It's actually the infrastructure. There, it is clear that we need a platform. We need support from software in order to be able to collect data and apply, and that help us apply these techniques. And there we are looking at architectures such as multi-tier architectures that enable the deployment of different modules such as edge computing or fog computing or cloud computing that provides the means to really deploy and apply AI. And finally, before I close, I would like to mention a few words for the EIT Regional Innovation Hub in Greece. So the hub mission is to create added value for the services and products of local manufacturing companies. The hub, through a call, has participated and has been selected. And then we have in our local ecosystem 33 actors coming from different areas, such as manufacturing, like companies that produce products, companies that are in so we shall call them original equipment manufacturer or machine shops, or integrators, ICT companies, and also we want to engage them in projects such as digital transformation, teaching and learning factories that are related to training and learning. So that is all from my side. Thank you very much for your time.
Thank you very much to Mr. Kosmas Alexopoulos from LMS. Mr. Figueira, I have a question for you. Can you hear me? Yes. You were mentioning that you can apply the Trust A framework in different artificial intelligence paradigms and to variety of problems. Can you explain us more about which kind of problem you were talking about specifically?
Okay, so that can be applied to both predictive and prescriptive problems, and that means that we can, with this method, predict some interesting variables like how much are we going to sell, or when are we going to have a failure, or how is the human going to behave so that the robot can adapt to that human behavior. Okay, so these are predictive problems that we can approach, but we can also approach prescriptive problems. I mean, these decision-making problems, like how do we have to sequence jobs in a given machine, production jobs in a given machine, or how do we need to control the process of some manufacturing operation? So should we increase the temperature? Should we decrease pressure? How are we going to control the process, right? So, or how are you going to route some optimize the routing of some vehicle that could be an automated guided vehicle inside the manufacturing plants, or it can be some vehicle that is going to distribute our products. So these are the kinds of problems that we can approach.
Thank you very much to Mr. Figueira. And with his speech, we are concluding here the last panel.